Welcome to Rges Algebra 1. This is lesson 24B. We're going to begin with a review on sections 10.1 through 10.6. Then we're going to have our focus instruction on 10.7, which is the assignment you have due on Monday. And then we're going to have a preview on the first part of our word problems on 10.8, so that when you get to class on Monday and you do not need to do anything else, you can jump right in to your homework lesson. Okay, so we'll begin with our preview. Our review. The first concept is how to do something like this when we have a binomial times a binomial, and what you want to be thinking is FOIL. Now, a few of you, as I've noticed on your tests and quizzes, still have some trouble on this. So for those of you who are struggling, let's look at this one step at a time. The first means the first term from each binomial. So we want to multiply 2x times 3x. 2 times 3 is 6, and x times x is x squared. So that's my first term. My outer term, standing for O, is the first term on the first binomial and the last term on the second binomial. So in other words, if I have 1, 2, 3, 4 terms in consecutive order, the 2x, the minus 5, the 3x, and the plus 7, I want to take the 2x and the 7. Those are my outer terms, and we're always multiplying here. So 2x times 7 is 14x. My inner terms want to be the ones closest together. That would be my second term and my third term, the negative 5x and the 3x. So you always want to include the sign, negative 5 times 3x. And that equals negative 15x. My last terms are going to be my second and my fourth term. They're the second one in each binomial. So this would be the negative 5 times the 7. And that would be minus 35. Now, when we do it in that order, the middle two terms will always combine. So you do not want to finish your answer there. You want to make sure you combine those middle terms. So our final answer will be 6x squared. If we have plus 14 minus 15, that leaves me with minus x minus 35. So if you still have not mastered that, so that that's easy for you, you want to go ahead and do some additional review, I would suggest you go back to page 412 and you review those again so that those become easy to you. Now, when we're factoring, this again is a review idea. By the way, if for these two ideas, if you were not here the first semester and this is difficult to you, I would also suggest you go back to chapter 5, because that's where these ideas are being taught. So if we were to review this one, I'm asking you for two numbers that their product is 33. So two numbers multiplied together to give me 33, and because this is a plus, their sum is 14. Okay, their product is 33 and their sum is 14, positive 14. And those two numbers would be 3 and 11. So I would get x plus 3 times x plus 11. I'm going to only do one more because we do have a lot to cover today and I don't want the whole thing to be reviewed. So the next one I'll do is minus 13x plus 36. This tells me my product needs to be 36, and because this is a plus, my sum needs to be a negative 13. I just typically think about the 13 and then I will make them both negative, okay, because their signs are the same to get a plus in front of the third term. So those two, let's see, 1 and 36 certainly would not work. 2 and 18 does not work. I'm looking for a sum. 3 and 12 is 15. That would not work. 4 and 9 are my values. See how that works? And they must both be negative. So it will be x minus 4 times x minus 9. The order doesn't matter between the 4 and the 9 because I have no number or numerical coefficient before my first term. Okay. So again, please review in Chapter 5 if that's still something you're struggling with. Now, greatest common factor, recall, we've gone over this a couple of times, but if I have two numbers and large numbers, easy, small numbers, you can kind of just look at it in your head. If I had a 12 and a 24, and I say, which the largest number divisible? In both, it would be that. If I had a 9 and a, let's see, 21, what's the largest number that goes into both of those? And this, I'm thinking in my head, I would just think 3. Or I could say, well, that's 3 times 3, and that's 3 times 7, so what's the largest one divisible into both? And that would be the 3. But if you have larger numbers that you can't see right away, and we've put some of these to almost to the point of exhaustion, let's say I have, let's say I have 56 and 32. And I think to myself, okay, well, 32 times itself, or 32 doubled, is not 56. So it's maybe not obvious to me what these two would be. So I'm going to divide this into any two numbers. This would be an 8 and a 7. This would be any two numbers that go in. Let's say I'm in the mood for 2 and 16. Let's see. So this is already prime, and this is already prime. Keep dividing into primes. That would be 2 times 4, and this would be 2 times 2. And so altogether on the left-hand side, that would be 2 to the third times 7. On the right-hand side, this would be 8 times 2, this is prime, this would be 2 times 4, this is prime, this would be 2 times 2, and altogether I would have 2 to the 5th power. Right? And I should maybe put my tree there so it's obvious that that 2 is not hanging out there for some other reason. Okay, this is a 2, 2, 2, 2, 2, 2. Okay. So what is the largest thing they both share? They both share 2 to the 3rd power. So 2 to the 3rd power would be 2 times 2 is 4 times 2 is 8. And that's the largest divisor into both those numbers evenly. We call that the greatest common factor. Now the next idea, we basically have 4 patterns here that we're working with. Okay, so the 2 basic overarching rules is always factor a greatest common factor first, and then always factor completely. So remember those 2 basic rules. So you always look, is there a number that divides evenly into these 3 numbers? And I say, yeah, there's 3 divides evenly. So I would be left with a 3 there, a 10 there, and a 16 there. Now, can I divide this part into binomials? Sometimes you cannot, but always check. Do I have 2 numbers that multiply together to give me 16 and their sum is 10? Yes. How about 2 and 8? So I'll have an x there, an x there, a 2 there, and an 8 there. Both additions, so that when I'm adding the outer and inner terms, I'll get 2x plus 8 more x, or 10x. Okay. Now the next idea of factoring would be if you had an example like this. I always look, is there anything that I could divide into every term? No, and when they're already grouped like that, that's not going to be so important usually, but I do see they share a binomial. So you take the binomial out, and most of you are getting this one very well, and what's left over, the x minus 7. Now, once in a blue moon, you might find that this could also be factored, or this could be factored. So always check, because our second rule is always factor completely. Now, a good trick or thing you need to focus on, perhaps, to know whether or not you're going to use your third tool is, do I have 4 terms? So if you have 4 terms, the next thing you should try is to see, well, can I divide these into, can I factor them in pairs? And so in the first pair, you could factor out an x, leaving you with x plus y. And in the second pair, I could factor out a z, leaving you with x plus y. Then if these two, if you can factor out a pair at a time, and those two binomials are equal, then we're back to example 2. We pull out the common binomial, and what is left over? X plus z. And again, I think that is one that you tend to be a little better at. Now let's go on to our next tool. Now, the reason that this one is not the same as number 2 above is because I cannot divide a common factor, a 2 or 3, into all 3 terms, since those are the common factors of 6. But I do have a trinomial here, so it doesn't look like 3. It doesn't look like 3 or 2. It looks like 1, but there's a couple of differences. One is that I have a numerical coefficient in front of my first term and my last term, and it might look a little more complicated. Now, when they're easy, they could be factored like number 1, but this does not have a common factor, so I'm going to take the product. 6 times 25, and that would equal 130, and that's the one I'm going to factor. In my mind, I'm thinking 1 and 130, 2 and 65, 3 and, let's see, that would go into 12. 3 doesn't go in evenly. Okay. 4 just don't go in evenly. Let's see, 5 goes in, and you'll get a 2 for 10, and 30 goes in 6, 26. And what am I looking for here? I'm looking for 2 numbers that their sum will be 25. So that does not work. Does 6 go in evenly? No. Does 7? No. Does 8? No. Does 9? Let's see, 10 and 13. Okay, I was struggling a little, and I noticed that I actually made an error right there at this point. So let me go back and correct that for you. This is actually 120 plus 30 more, or 150. So, so now I'm going to have to correct everything else over here. And here's the one that's going to sum to 25. So we will split the middle term, 6x squared plus 10x plus 15x plus 25. We're going to factor pairs. We're going to say that the 2x goes into both of those, leaving me with a 3x plus 5, and a 5 goes into both of those, leaving me with a 3x plus 5. Pulling out my common binomial, and what is left. So I'm giving you one each of all these examples again, because there are a lot of them, and it's fairly complex to remember each of those. Now, the last one we did was in class last time was we were teaching you the idea of multiplying together to get a product of 0. Now this is the lesson for this time, the homework that will be due on Monday. And so the basic idea is if you take any two numbers and you multiply them together to get, and your answer is 0, we know that either x equals 0 or y equals 0. I'm going to use that by setting an equation to 0. So we've moved from factoring now to solving equations. My method is going to be either number 1, set the equation to 0, number 2, factor it, and number 3, solve for two answers using this principle right here. I'm going to illustrate that a couple times. If it does not factor easily, your second choice is to use the quadratic formula. Now notice for my first example, it is already set to 0 and it's already factored. So all I have to do is solve twice. Either the first binomial will equal 0 or the second binomial equals 0. Solving each for 0, solving each for x, I'm going to get either x equals 9 or x equals 2. I'll go ahead and write this in a notation like this. Typically, I always write chronological order, but it doesn't really matter, and he doesn't seem to, so I don't care. All right? So that would be typically how you would do number 3 through 15. Now, sometimes the answers, of course, will not solve as simple as that. Maybe the factored combination would be 11x plus 17 and 2x minus 13. So when I'm solving, let's just do the second one. I would say 2x minus 13 equals 0. Take the whole number, or take the number value, the constant, to the right side. 2x equals 13, divide by 2, and x equals 13 halves. And you would then have to solve the left half as well. Now let's look again at the second section, 17 through 39. Now notice in this section, we've already got it set to 0, but we will want to go ahead and factor it and then solve each side. So I'm going to illustrate that, and you think along as best you can on how you would do this problem, and then compare your notes with mine. Let's take a look. We factored this out. We need two numbers that multiply together to get you 21, and that add together, sum together to get you 10, and then we'll solve it twice, the left side and the right side both set to 0. Let me give you an example that it's a little more complicated. So I worked this out. This is, now look, you're observing here that you're going to get all kinds of practice with factoring. That's the first thing I'd like you to notice. So go carefully through each problem. Now, this one was one of the more complex ones, so we went ahead and multiplied those two together to get 80, factored 80 till I got a sum of negative 24, so they'd both be negative. Once I got that sum of 24, I would split my middle term and then turn it into a grouping. Now, this might be the one thing that seems odd to you, either this sign, probably this. Okay, if I am taking out a negative 4, then my first term will end up, if I multiply back, to be negative 20x, but I might be inclined to just pick up this positive. But recall, if I put a positive 4 here and I multiplied through, I'd get a negative 16. So be very careful with your sign when you're going from there to there. Easy place to make a mistake. Okay, so pause it and convince yourself by distributing back that that is actually the correct way to do it. Make an intentional focus on that. Now, because the product equals 0, I'm splitting it into 2 parts and going ahead and writing out it in set notation when I've finished it. The last thing we're going to do now is a preview, and we're looking at word problems in 10.8, and this is rather difficult for students, so we're going to take it in groups. And this time, again, this would be the homework you'd begin Monday that's due next Wednesday. We're going to look at 2 kinds of problems, age problems and consecutive integer problems, and I'm going to illustrate a couple different ones for you for each. So we'll begin with the age problems. Our first problem is going to be R is 4 years younger than S. This is an age problem. The product of their ages is 96. So this very simply reads out into 2 equations. Look at it. R is. Is would be my equal sign. R is 4 years younger. If he's going to be 4 years younger, we're going to start with S and subtract 4. The product of their ages, R times S, is 96. There we go. Is again is the equal sign. Now this would be, we have 2 equations. We're solving for 2 variables. You know how to do this, either by linear combination or by substitution. This one is ideal for substitution because we have R equals something. So we're going to take that and plug it in every time we see an R. We'll say S minus 4 times S equals 96. We're going to expand that by distribution. S squared minus 4S equals 96. And now I'm going to use what I've just been learning. I'm going to set my equation to 0. I'm going to factor, and I'm going to solve each side, the left factor and the right factor, to set each to 0. Now, whenever you're doing a word problem, apply a little logic. We're asking for their ages, so nobody's going to be negative 8 years old. So this is my correct answer, and then it asks, and then always go back to the question again. Find each one's age. So if S is 12, R is 4 years less, go back to my original statements, and so R is going to be 8. And that's the answer to the equation. Now let me look at another one for age problems. Look at number 6. That's not one you're going to be assigned, so let's look at that one. It says L is 2 years younger than M, is, or my equal sign, 2 years younger, so we'll have to subtract 2 from M. It says the difference between the squares of their ages. So if I take, now let's see, we already just told us that that L is younger, so let's take M first to take the difference, the square. So we'll take M squared minus, that's my difference, L squared, the difference between the squares of their ages is, there's my equal sign, 28. So what would I do to solve this one? I would take the value, the expression that represents L, I'd plug it in here. We're going to have an M squared minus M minus 2 squared equals 28. You'll need to expand this. Then I will have to simplify my left. My M squared minus M squared cancels out. That's going to make it much simpler here. Minus 2M plus 4 equals 2. Okay. My 4 will transfer over. I'll get a negative on the right and the left side. I'll divide, and my M will be a positive number. And from that point, you can solve the M and the L. Now let's look at one more type of problem. The key to consecutive integer problems is to realize that think about a number line. If the first one were 1, and the next one would then be 2, and the next one would be 3. Okay. So if this is my beginning point, my x, and then I would have, what's the difference between these two? I would have x plus 1. And what's the difference between my starting point and 3? X plus 2. So if I said, find two consecutive integers whose product is 9, there would be my first integer, and this would be my second. So their product would be 90. And then you would distribute and solve. How would I solve that one? X squared plus x, pull to the left, minus 90 equals 0, set to 0. Let's see. 9 and 10 would have a difference because this is a negative of 1 if I put the larger one as positive. So I'm going to have x plus 10, x minus 9. Solving, I would get x equals negative 10 and x equals 9. The problem did not tell me that they would have to be positive, so I could either have negative 10 and the next consecutive one to the right is negative 9, a grouping like that, or 9 and the next consecutive one is 10. Okay. Now these are the consecutive integer problems are actually easier because notice I'm only using one variable, not two variables. Okay, and so that's nice. And the reason why is it's so easy to identify the relationship between one and the other. Now, if you had consecutive odd integers, the last idea here, let's say I have on my number line, if this were x and I want to go to the odd one, it would not be this one, it would be this one. So my relationship would be x. For the second one, it would be x plus 2, would not be this one, but be this one. Compare still to the original. That would be 1, 2, 3, x plus 4, etc. Okay, and pay attention if they're asking you for negative or positives, otherwise include both. And I think that's enough to get you going on that.